In Objective 5, we're going to learn the derivative for all 6 trig functions. We've already done the derivatives for sine and cosine, so we're going to go ahead and write those down again. Derivative of sine is cosine, and the derivative of cosine, we'll remember, is negative sine. All right, so let's get into the others. The derivative of secant is secant times tangent. And the derivative of tangent is secant squared. Okay, over here we have the derivative of, we'll do cosecant now, is negative cosecant times cotangent. And the derivative of cotangent is negative cosecant squared. So a few things that I want to point out. The derivative of any trig function that starts with a C is negative. The derivative of cosine is negative. The derivative of cosecant is negative. And the derivative of cotangent is negative. However, everybody else has a positive derivative. Okay. Next thing I want to do is give you a way to remember these 4 new ones. And we're going to do that by using SSTCCC. So I don't really have a good name for it. But SST is going to be your secant and tangent. So we're going to write it out here. Secant, tangent. And then CCC stands for cosecant, cosecant, cotangent. The only thing you have to do here with the CCC is remember to put a negative on it. And what we want to do is just put one negative. We're going to put it on the center term. So a little negative cosecant there. What happens here is anytime I take the derivative of secant, let's say I start with secant here, the derivative of secant is the remaining 2 terms, secant times tangent. And if I start on the opposite end with tangent, the derivative of tangent is the other 2 terms, secant times secant, or secant squared. Right, so we're going to do the same thing here with cosecant, cosecant, cotangent. The derivative of cosecant is negative cosecant times cotangent. That's what we had here. And the derivative of cotangent is negative cosecant times cosecant, or negative cosecant squared. Okay, so we're going to use this tool to remember. You do have to remember, of course, what the SST stands for. So secant, secant, tangent, cosecant, cosecant, cotangent, and don't forget your negative. A few other things that we'll review because we'll need them here in using trig functions would be our Pythagorean identities. So a Pythagorean identity is a trig identity that follows that a squared plus b squared equals c squared pattern. And the first one we have is sine squared plus cosine squared is 1. If you can remember that one, you can always derive the other 2. So if we divide all 3 terms by sine squared, we end up with 1 plus cotangent squared is equal to cosecant squared. And instead, if we divide all 3 terms by cosine squared, we end up with tangent squared plus 1 is equal to secant squared. And so notice in the Pythagorean identities, sine and cosine are grouped together. Remember that in their derivatives, sine and cosine go together. Down here we have cotangent and cosecant are also related to each other through the Pythagorean identities. And you'll notice cotangent and cosecant are also used in each other's derivatives. You'll notice also tangent and secant belong together in the same Pythagorean identity and that they belong together in each other's derivatives. Okay, so just a kind of way to help you remember which functions like to go together. And then the last one is your double angle formulas. And honestly, the only one I think you'll really come across is sine. Sine 2 theta is 2 times sine times cosine. So if we do come across one of the others, like for cosine, we'll add that to it. All right, but that's all we need here in order to move on to some examples. So let's do some examples with some trig. All right, starting with the function x minus tangent x. So the derivative here of x is 1. And just looking back at your chart, remember the derivative of tangent is secant times secant, or secant squared. Which feels pretty nice. Just leave it that way. You've taken the derivative. But if you can simplify it, you should. So if I look back at my Pythagorean identities, 1 minus secant squared. So if I start with positive 1 and subtract secant squared over to the left, I would need to then subtract tangent squared over to the right. So this simplifies to negative tangent squared. So if you can simplify, you need to simplify. Okay, our next problem. Y equals x squared times secant x. All right, so here, instead of being attached, the two terms, by subtraction or addition, they're attached by multiplication. So remember, you have an x term here, and you have an x term here. And you're being asked to multiply the two things together, but we can't. So this is function 1, function 2, and we have to use the product rule to take the derivative here. Okay, so remember the product rule is first times the derivative of the second. And looking back, the derivative of secant is secant plus our second term secant times the derivative of the first term. So the derivative of x squared is going to give us 2x. So again, you would clean up anything that you can here. There's a little bit that we can factor out. So you notice both terms have an x in common and a secant. So we'll factor out x times secant. And what are we left with? We're left with x times tangent plus 2. In example 3, we're going to let f of x be 1 minus cosine divided by sine. So with fractions, we can use our quotient rule. However, anytime there's one term in the denominator, it's possible that we could simplify the fraction first and then take the derivative. So if we want, we can split up our fraction for our function here, 1 over sine minus cosine over sine. So this is still f of x. I haven't taken the derivative yet. All I did was go backwards from having like denominators and adding them together. I just took that like denominator and split the terms back into two parts. So now I want to simplify my function even more. 1 over sine becomes cosecant. And cosine over sine becomes cotangent. So now this is a nice simpler form. I don't have to use the quotient rule to take the derivative. I can just do the derivative of each trig function individually. So that's what we're going to do now. So remember, these are both functions that start with a c, so each has a derivative that is negative. The derivative of cosecant is negative cosecant cotangent minus, and we want to watch out here, this negative carries down. The derivative of cotangent is negative, so I get another negative. And the derivative of cotangent is cosecant times cosecant, or cosecant squared. So I do have a double negative in here, so we're going to change that back to addition. And then we can do a little factoring. So what can we take out here? We can take out a cosecant. So if I factor out cosecant x from each term, I'm left with one more positive cosecant over here minus cotangent. All right, problem number 4. So if I ask you to do the same thing here, again, this one's a little bit different from number 3. I have 1 minus cosine squared. Instead of splitting it up into 2 parts, I know that 1 minus cosine squared is part of a Pythagorean identity. So if we go back up here to the top, we have 1, subtract cosine squared over to the right, and we're left with sine squared. So this first simplifies to sine squared over sine. And sine squared over sine would reduce to sine x. So now we're simply taking the derivative of sine x. Get cosine, and that's it for example 4. So this actually works a lot of the time with anything, with any derivative. The more you can simplify the original function before you get started, the easier the derivative will be to take. So you want to make sure that you follow that process. In our last example, I'm going to ask you to find the second derivative. For the function y equals 2x times cosine x minus 2 sine x. All right, so that's our function. Remember, if you can clean anything up first, you should. There's really nothing we can do here to this one. I know they have a 2 in common that could factor out, but that's really not going to be helpful. So we're going to go ahead and start our derivative. When I get to the first terms, I notice that I have a 2x times a cosine x. So one variable times another variable. And that calls for the product rule because I can't actually multiply the 2x terms together beforehand. So we're going to call 2x our first term, cosine x our second term. And once we've done the product rule here, we'll follow up with the derivative of the negative 2 sine x term. So again, starting with the product rule. So we have the first times the derivative of the second. So that's going to give us negative sine plus the second times the derivative of the first, 2. Okay, that's it. We've done our product rule there. Then we have to follow up with the derivative of negative 2 sine x. So negative 2 is our constant, so we'll just keep that negative 2. And the derivative of sine is cosine x. So I should say negative 2 is our coefficient, so the coefficient will stay. And the derivative of sine is going to give us cosine. All right, so now we want to clean this up some. All right, so we have a negative 2x sine x plus 2 cosine and minus 2 cosine. So these two terms right here are opposite. Positive 2 cosine and negative 2 cosine. So they're going to add up to 0. So those two terms are going to drop out, and this is going to be our derivative. However, this is just our first derivative. We need to get to the second derivative. We're going to take the derivative of this again. So y double prime. Now, to take the derivative again, remember, we have 2 variables here, negative 2x and a sine x. And they're trying to multiply each other, negative 2x times sine x. Since I cannot multiply the two terms together first, that means I have to use the product rule. So first term is going to be the negative 2x. Second term will be sine x. And our product rule says we have first times the derivative of the second, so the derivative of sine is cosine, plus the second times the derivative of the first. So that's going to give us a negative 2. All right, our job now is to clean this up. You'll notice they both have a negative 2, so I could factor that out. See if it leaves me with anything that seems nice, unless it's x times cosine plus sine. So nothing we can do to simplify what's left inside, and so that is our second derivative. And it's our final answer.